Hi everyone, welcome back to our YouTube channel. In today's video, we'll be looking at similar problems to the one we did in our last video section. Similar problem to the Gaussian integral we tried to solve last week. As I promised, I was going to be solving something similar to explain further what we did in our last video. So today we'll be looking at this given integral. We are told to evaluate the improper integral and to find the value of I. So without wasting much of our time, so let's dive straight to the action. So we're using a standard trick for this integral. We are given I is equals to integration from negative infinity to positive infinity exponential raised power minus x squared over 5 dx. So we want to integrate this improper integral. So we're going to be using a very standard trick, a common trick of you are going to apply the idea of I square is equals to I times I. So we're going to replicate this integral again. We're going to repeat it. So this is what we're going to do. We're going to be using this. Going to be square over 5 dx times then another integral, same integral. Well, let's call this y instead of x. So y square over 5 dx dy. So we'll be using this approach to solve to evaluate for I. So now let's simplify. So applying this, we have I squared is equals to this will give us combine it infinity infinity uh, minus I squared over 5. Then we have the y. So now this will give us adding, so we know that minus is common, so bringing it out, then we add x squared over 5 plus y squared over 5. So to give us something like this, I squared over 5 dx dy. So now to solve this, now we are at this junction. You see, this our main aim, getting something like x squared plus y squared has always been our main aim from the beginning. That's the main reason we apply and we employ this I squared is equals to I times I. So now let's convert this. This is in Cartesian coordinate. Now let's convert it to polar coordinate. So to convert to polar, we say x is equals to r cos theta, y is equals to r sin theta. Then let's solve this. Is equals to r squared into bracket cos squared theta plus sin squared theta. And we know from our trigonometry identity, cos squared theta plus sin squared theta is 1. So this gives us r squared. So now let's get the limit for radius and angle. So to get our new limit, because we are converting from Cartesian to polar, so we're changing from x and y to r and theta. That is r our radius, then and our angle theta. So now we're going to find the new limit as well. So to get our limit now, what we just need to do is to try and sketch the coordinates here. So let's say something like this. So we know our y both are negative infinity to infinity. So let's and we know what infinity means. Infinity means something that is unending, that's no end. So let's assume this is my infinity here. Then this is my negative infinity. Then for the x as well, same thing, same thing. So now, so this is our sketch now. This is sketch of the entire plane because it, the limits are from negative infinity to from negative infinity to infinity. So we're basically just doing the entire plane, the entire plane. That's what we are sketching. So then this will give us our radius. This is our radius r, our radius r. Then now for our angle now, for our angle theta, as you can see, is about the entire plane. So just the entire plane. So now this our theta starting from here, our angle theta starting from here to come back here. So now, and this is our radius. Our radius is starting from the origin, then that is to the border of the circle, which is infinity. So now from this now we can see our radius has the limit of this. Then our theta now, our theta is starting from this point, starting from 0. Then it's a full circle. So for the whole axis, so it's going to be 2 pi. So this is our limit for the new uh, polar coordinates. So this will be our upper and lower limit. Get our new full integral now. Our new full integral in polar form will be, so let me adjust this so you cannot see from this end. So, so our new limit now, our new integral, will be I square is equal to 0 to 2 pi, that is for the angle, then 0 to infinity, that is for the radius. Then don't forget what we did here, exponential minus x square plus y square, which is now what, r square. So don't forget minus r square over 5. Then as well, one more thing, our dx dy in polar coordinate, our dx dy will become r real d theta. So don't forget this. So adding it here now, r dr the theta. So now evaluating and solving this now. Let's solve the inner part first. Let's deal with the radius part, then later we'll do the other part. So now for the radius part, let's take it r square over 5 r dr. So let's apply substitution. Let's u equals r square over 5. So what we just need to do is differentiate. The u becomes 2r over 5 dr, then which gives us dr to be 5 du over 2r. Now let's substitute this dr into this. So we have infinity. Our limit will remain the same because when you insert 0 into this r, 0 square over 5 is 0. Then when you insert infinity, infinity square is infinity, then infinity over infinity over 5 is infinity. So don't forget our r square over 5 is already u. Then r Then what is our dr? Our dr now is 5 du over 2r. R cancel r, so we are left with 5 over 2 is a constant, bring it out. So go to infinity a minus u du. So now when we integrate this, it's very straightforward. Integrate this. That is, how do we integrate it? We differentiate the power of the exponential, then we multiply it by the inverse of that differentiation. So this will give us, don't forget our constant, times 1 over 1. This is what I mean. We even differentiate minus u, we get minus 1. So multiply it by the inverse of that, which is 1 over minus 1. Then we insert our limit. So now this gives us 5 over 2 is equals to infinity. We can as well bring the negative outside. So we are left with minus infinity minus 0. Then we know that 0 minus 0 is 0. Then exponential raised to power 0, anything raised to power 0 is, as we all know, is 1. Coming to this minus negative infinity, when we do this negative infinity, exponential raised to power of negative infinity will give us 1 over exponential infinity, positive infinity. Then this now 1 over exponential negative, positive infinity gives us 0. So 1 over, so give us infinity. So 1 over infinity is 0. So this is what I'm trying to say. Let me break it down. Like I promised I was going to break it down. So this will give us 1 over infinity. Then like I said, this one is 1 already. So this gives us 2. So 1, this exponential infinity is infinity. So 1 over infinity minus 1. And I said 5 over 2. Then 1 over infinity is 0. So now this gives us positive 5 over 2. So this integral now, the inner integral minus r squared over 5 r dr is 5 over 2. Now let's insert it and substitute it here. Then our I square becomes 2 pi 5 over 2 d theta. And this is a constant to bring it out. 5 over 2 pi d theta, which is 5 over 2 pi 5 over 2 then theta, just like saying 1. So when you integrate 1, you get theta, that is what we are integrating with respect to. If it's x here, it will be x. If it's the x, it will be x. So as it is the theta, it is going to be theta. So infinity. So this limit is 0 to 2 pi. Insert it. This will give us 0 automatically. So I left with 2 pi. So I square now gives us 5 over 2 times 2 pi, which is equals to 5 pi. So now I square is 5 pi. Got it. Then I now will be taking the square root of 5 pi. So finally our I is 5 root 5 pi. So this brings us to the end of this video. Please like and subscribe. Watch, subscribe. Thank you very much.